consistent pace produces the best results. Before the AI revolution we see today, sequence modeling was dominated by recurrent neural networks. But RNNs had a fundamental problem. They processed data sequentially. To understand word number 50, the model had to pass through words 1 through 49 first. This created a massive information bottleneck and made parallel training impossible. We needed a way for models to look at everything all at once. In 2017, the paper Attention is All You Need changed everything. It introduced a mechanism inspired by retrieval systems. Think of it like a library search. Every word in a sentence is assigned three vectors. First, the query, what the word is looking for. Second, the key, like the label on a file folder that describes what that word contains. And third, the value, the actual information itself. By comparing the query of one word to the keys of all others, the model calculates exactly how much attention to pay to each piece of information. Now let's look at the math. To find the relationship between words, we take the dot product of the query and the key matrices. This gives us a raw score of compatibility, but as dimensions grow, these scores can become dangerously large, causing the gradients to vanish during training. To solve this, we scale the result by dividing by the square root of the dimension dk. We then pass it through a softmax function to turn those scores into probabilities that sum to 1. This creates a filter. Finally, we multiply this filter by our value matrix. The result, a new vector that isn't just a word but a word soaked in the context of everything around it. In production, standard multi-head attention has a massive bottleneck memory bandwidth, storing keys and values for every single head. What we call the KV cache consumes huge amounts of VRAM. Modern models like Llama 3 use grouped query attention or GQA to solve this. Instead of every query head having its own key and value, multiple query heads share a single key value pair. This reduces the cache size significantly, allowing for longer context windows and much faster generation speeds. It is the difference between a model that can read a paragraph and one that can remember an entire book. But there's one last detail. Attention is naturally bag of words. It doesn't know the order of words. To fix this without breaking the math, we use rope or rotary positional embeddings. Instead of just adding a fixed vector, we rotate the query and key vectors in a complex 2D plane. The amount of rotation depends on the word's position in the sentence. This is brilliant because the relative distance between words is preserved through the angle between them. This geometric awareness is why models can now handle sequences hundreds of thousands of tokens long, from sequential bottlenecks to rotary geometry. The attention mechanism is the engine of modern AI. Understanding it is the key to mastering large language models. Thanks for watching and subscribe to my YouTube channel, that is Adarita Biswik Nima.